Welcome to the AI Research Roundup. I am Alex. Today is June 9th, 2025. We're looking at a research paper titled Qwen3 Embedding, Advancing Text Embedding and Reranking Through Foundation Models. This paper, published just 4 days ago on June 5th, 2025, from Hugging Face's trending list, introduces the Qwen3 Embedding series. It's all about improving how AI understands and ranks text using Qwen3 foundation models. The key idea is a multi-stage training approach, even using the Qwen3 LLMs themselves to create high-quality training data. This helps create better text embeddings, which are numerical representations of text, and more effective re-ranking models, which refine search results. Alright, so this first figure shows us the model architecture for both the Qwen3 embedding and the Qwen3 re-ranker. For embedding, shown on the left, an instruction and query, or a document, is fed into the Qwen3 model. The actual embedding is then taken from the hidden state of the end-of-sequence token. For re-ranking, on the right, an instruction, query, and document are processed by Qwen3, and then an LM head, that's a language model head, determines the probability of a yes answer, essentially classifying relevance. Okay, building on that architecture, this next figure details the training pipeline. It's a 3-stage process starting with the Qwen3 model. Stage 1 is weakly supervised pre-training, where the model learns from large-scale synthetic pair data. Synthetic data is artificially generated by the Qwen3 LLMs. Then, Stage 2 is supervised fine-tuning, using high-quality synthetic and labeled data, where correct answers are provided. Finally, Stage 3 involves model merging, using spherical linear interpolation to combine different trained versions, producing the Qwen3 embedding and Qwen3 re-ranker models. Following that training pipeline, this table details the model architectures. We see different sizes, 0.6b, 4b, and 8b, each with a specific number of layers. All models can process a sequence length, that's the maximum number of input tokens, of 32K. For text embedding models, the embedding dimension, which is the size of the numerical vector representing text, increases with model size. These embedding models also support Matryoshka representation learning. This capability allows for custom embedding dimensions, and all models are instruction-aware, adapting to task-specific instructions. Alright, so this table now presents the performance results on the MTEB Multilingual Benchmark. MTEB. That's the Massive Text Embedding Benchmark, is a standard test suite for evaluating how well these text embeddings perform across many languages and on various tasks. We can see the Qwen3 embedding models, including the 0.6b, 4b, and the 8b versions we discussed, compared against other open source and commercial API models. And the results are quite impressive. The Qwen3 embedding 8b model achieves a leading mean task score of 70.58, even surpassing strong proprietary models like Gemini embedding. So, to wrap things up on these Qwen3 models, it's clear they represent a significant step forward. The two big takeaways for me are, first, they're truly state-of-the-art performance that we saw on benchmarks like MTEB. And second, that very clever multi-stage training approach, especially using the Qwen3 LLMs themselves to create high-quality synthetic data. This is super useful for things like Retrieval-Augmented Generation, where systems fetch relevant information to craft better answers. The fact that these models are open source is also a huge plus for the research community. That's our roundup for today. Thanks for joining.